Welcome back to AIQuantEasy. In this episode, we'll continue to talk about the supervised learning on stock prediction. Recall in the previous episode, we talked about how we label daily stock records based on our definition of what is a good day. We implemented the labeling strategy and visualized the labeled stock data as we see here. So now we have the labeled stock records. That means we have training data. Then we can start to talk about how we train a supervised learning model such that it can make a prediction on a day without label. Like for today, it can make a prediction if today is a good day to buy or not. Okay, let's start to look at the code, how we train a supervised learning model. We will use a package called scikit-learn to do the supervised learning training. If it's your first time to use scikit-learn, please use this command on the Anaconda prompt to install this package. You can use pip3 to install or pip to install scikit-learn. Okay, once it's installed, then we can import a supervised learning model. So in this particular example, I will use a random forest. There are a bunch of other supervised learning models provided by this package. We can try all those things in the same manner that we try random forest. And also, we want to test the performance of our model after it's trained. So we import this accuracy score class from the scikit-learn metrics package. So first of all, we want to drop all the rows from our data frame that contains null value. Recall that the several rows in the beginning, they may not have the values for those moving averages and so on, right? So we want to drop them. And also, the rows at the end, they may not have the label values because, for those days, we may not have determination yet, right? We want to drop them as well. So we drop all the rows contains null value. Then what we want to do is we want to split the labeled data into 80% training and 20% testing. We want to train our model on the training data set. Then after it is trained, we want to test its performance on the testing data set. With this regard, we want to have the 80% earlier data as a training, then the 20% most recent data as testing. For doing so, we first sort, make sure that our records are sorted by index, which is date. Then we determine the splitting index. Again, we want 80% of the early portion of our records to be the training. Then basically, we use the total number of rows that we have in our data frame multiplied by 0.8. Then we get the index of splitting. We use this ILOC method to do the splitting, right? For training data set, we want to start from very beginning, first row, all the way to the row right before this splitting index. Column-wise, we want to include all the columns. For testing data set, we want to start with the record at the split index all the way to the last record. Column-wise, we want to include all the columns. So now we have the training data set and the testing data set. We further split the training data set into X-train and Y-train. Basically, X-train contains all the rows with the columns of all those input features, including all the prices, the volume, and all the indicator values, but exclude the label column. So that's why here we drop the label column, right? We want to put the label column into Y-train. So Y-train contains the label column, only the label column. And X-train contains all the columns of the input features. The same thing for the testing data set, we split them into X test and Y test. X test contains all the columns of the input features, and Y test contains the label column for testing data set. Okay, once I have the training data set, testing data set ready, then what I'm doing is I create an instance of this random forest classifier. Later on, we will talk about how random forest works. Basically, the random forest is a ensemble of multiple decision trees. So here we specify how many decision trees that we want to have. And for this parameter, we always use 42 as a default value. So we create an instance of random forest classifier. Then we simply call fit method to train this classifier on the training data set, including both Xtrain and Ytrain. Xtrain provides the records of the input features, and Ytrain is the training records with the label column. So basically, this fit will train the model such that the model will learn how to map the values of the input features to the values of the label. So once this model is trained in this way, then we can call predict via this train instance to make a prediction on each record in the testing data set. So basically, this model will automatically assign a predicted label to each record in the training data set. So we call the predicted value as yPredict. Since for each record in the testing data set, we already know its real value, real label value, right? So that's yTest. Then we can compare yTest with the predicted value generated by the model. So we compare yTest with yPred. So in this way, we can calculate what is the prediction accuracy. Once we get the accuracy, we print it out in percentage. So this gives us a feeling how this model works, right? Should I trust this model or not, right? Okay, so that is basically how we train and test a supervised learning model in this particular example, random forest classifier. Again, you can use the same manner to train a support vector machine classifier or to train a linear discriminant analysis classifier or gradient boosting classifier in the same manner. Create an instance, train on the training data set, then test on the testing data set. Okay, let's just run the training and the testing, right? So in order to run the training and the testing, basically, we need to load as many records as possible from Yahoo Finance, right? So like I mentioned in a previous episode. So that's why I try to load the max number of records, right? So there's a multiple years worth of data, so it may take some time to load to visualize. But let's just run it from beginning. Load the data, derive indicators, then do the stock visualization, then do the labeling, then visualize the data, then training and testing a supervised model. Again, it takes a little time for this to run because we have multiple years worth of data. Since the results come out, see, the training, this is the training data. We print out the training data, right? So training data goes from 1993 all the way to all the way to 2017. Okay, so we use the records in this area, in this range as a training data set. Then from 20, whatever left here to now use as a testing data set. Okay, so we got the accuracy rate 57.92%. So this is not a super good performance, right? So it's not much more than tossing a coin, right? Tossing a coin, you have 50% accuracy rate, right? So we definitely need to make some improvement, right? So there are several ways we can make improvement. First of all, we can add more indicators, especially some of the indicators not directly derived from the price and volume information directly of this stock. We can have some indicators of the whole market, like VIX, the fear index, or some other sentiment information of the market, right? So that's one thing. We can add more indicators. Another thing is we can try different classifier, different supervised learning model. I mentioned support vector machine, like even k-nearest neighbors or neural network type of approach, and so on, right? We can try different things. I think different models might have different performance, slightly different performance, actually. Another thing is for right now, we view each individual record, each daily record as an input, right? As an instance. But instead of doing that, what we can do is we can use a sequence of recent daily records, including the current day, as the input instance. If that's the case, we can use a more state-of-the-art technology to deal with it, to deal with a sequence of data as an input, such as we use a recurrent neural network-based approach like LSTM, or we can even use the latest transformer technology as a on-the-leaf architecture for supervised learning. We will talk about that later on, okay? So stay tuned.